All right. Hopefully, you've had an opportunity to take a look at Solutions 3 worksheet or quiz, and hopefully you were successful. Let's take a look at these questions and see where the issues were. So if you had misunderstandings, pay attention here. Feel free to stop this anytime to listen and rewind and review it again. Okay, so first question. What's the total number of moles of H2SO4? Again, sorry, it broke up like that. What's the total number of moles of H2SO4 needed to prepare 5 liters of 2 molar solution? So basically, we were doing the molarity solution, but in this case, we have molarity, we have the liters, we don't have the moles. So you have to solve for the moles up on top. So you put in your molarity, you have your moles as X, and then 5 liters on the bottom. This is an easy one because you guys like cross multiplying and dividing. And you can do that when you have two fractions opposite on either side of a equal sign. So it's just going to be 2 times 5, and that's 10. So the answer is 10 moles. This one here, this is based on reference table G. What's the maximum number of KCl that will dissolve in 200 grams of water? That's a trick right there, 200 grams of water. Table G is based out of 100 grams. So what you have to do is you have to say, okay, where does KCl pass or cross the 50 degrees Celsius line? So I've marked 50 degrees Celsius right here. There's 50, all right? Where does KCl, let's find KCl, KI, KKK. There's KCl right here. KCl, it's this line right here. That crosses right about there, which is about, looks like about 42. Hey, there's the answer, right? No, that's not the answer, because you have to say, all right, 42 grams are soluble in 100 grams, but how many grams are soluble in 200 grams? And that's just a simple proportion, so that's why it's 84. Number 3, again, is a molarity question that's asking you, okay, I've given you the moles, I've given you the liters. Can you find out the molarity? Well, that's easy. It's 0.5 moles over 0.5 liters, and that sounds like 1. So it's 1 mole. 1 molarity, excuse me. Why not 1 mole per liter? Number 4 is asking you to use parts per million formula. The parts per million formula has the mass of the solute divided by the mass of the solution. And this is the trick. Now, for this question, it's not so much of a trick, but the next one it is. Remember, the solution is the combination of the solute and the solvent. So in this case, we have the mass of our solute, which is right there, 0.025 grams of lead nitrate, over the solution, which is 100.025. So in this case, the additional mass of the solute to the solvent really doesn't make a whole lot of difference in our solution mass. So it's basically 0.025 divided by 100, and that's how you can get this answer. The next question, however, and then you multiply by a million. The next question says it's 30 grams of solute in 70 grams of water. Well, in this case, it does make a difference. Now you have 30 divided by 100, and that's going to make, then the 100 is the solute of 30 plus the solvent of 70. So 30 divided by 100 times a million. And that's how you get that part per million solution. And again, it's just 0.3 times a million, or 10 to the 6, which would be 3 times 10 to the 5th. So there we go. 0.3 times 10 to the 4th. Anyway, for this question, it says, what's the molarity of a solution that contains 20 grams of calcium bromide in a half a liter of solution? Well, molarity is all about moles per liter. We're going to need moles, but we're given grams. So what do we have to do? What must we do? Yes, that's right. You're gonna convert grams to moles. And how do we do that? Well, that's in the reference table, table T. All right. Number of moles is equal to the given mass divided by the gram formula. So what's our given mass? Well, our given mass is 20 grams, and our gram formula mass is going to be the calcium plus 2 bromines. Wow. Look up on your periodic table, and you'll find that calcium is 40.01. Bromine is 79.9, basically 80. So 40 plus 22 times 80, which is 160. We get 20 divided by 200, which is a tenth of a mole. And so now it's all we have to do is the tenth of a mole over a half a liter, and a tenth, 1 over 5 is, you got it. Number 7 is asking, okay, reference table G, again, 30 grams of ammonia. Well, here's my ammonia line right here, and 30 grams of that in 100 grams of water at 20 degrees Celsius. So let's see here. Let me make a little mark. Make a mark right there. All right. So if the ammonia line is way up here, so if ammonia is soluble 55 grams is soluble. 55 grams of ammonia is soluble in 100 grams of water at 20 degrees Celsius. What would you classify the 20 grams as? Or 30 grams? Well, it's under the line, so therefore it's unsaturated. And if it's unsaturated, we're not going to have any excess ammonia solution in there. Number 8 saying, what's the total number of moles of solute in 2 liters of 3 molar solution? All right, so molarity equals, let me change my cursor, molarity equals moles over liter. We have our moles. No, we're looking for moles. Again, it's one of these. We have 3 molarity equals X moles over 2, so cross multiply, you get 6. And the last question on this review. Solution of sodium nitrate, NaNO3, in 100 grams of water at 10 degrees Celsius. There's the sodium nitrate right up here. 10 degrees Celsius crosses it right there at 80 grams. How many additional grams? It says it has 70 grams in it. How many additional grams are making it saturated? Well, if we're here at 70, how many more do we need? Yes, we just need 10. All right, nice job, everyone. Hopefully you got this. If you need to review a couple more, go back and